Kia ora Year 11 and Year 12s who are redoing AS, and Ben, Tausif and Snehal. This video is going through some of the Stats 1 paper 53, from November last year. And I'm just going to make my way through the whole thing, but in this video, just the first 3 questions for you. Question 1, which is a perms and comms question. Question 2, which is a boring but good example of a back-to-back stem and leaf. I think stem and leaf diagrams are always boring, but they're one of the most useful display methods in stats in real life, so well worth getting the hang of. And then the last question requires us to draw a histogram and then to find the mean of the stuff. And then the rest of the questions are here, but I'm not going to do them in this video. So let's first look at this one about 26 members of the local sports club, including Mr. and Mrs. Khan and their son Abad. The club is holding a party for Abad's birthday, but there's only room for 20 people to attend. So how many ways can we choose the 20 people from the 26 members of the club? And his parents, Mr. and Mrs. Khan and Abad, all have to be included. So we don't really have to choose 20 people here, right? We've got 26 people and the party can only fit 20. Really what we're doing is we've got 3 people who are fixed, and then we have to choose 17 from 20. So when you're looking at these questions, I want you to think about whether you're doing an arrangement or a permutation or a combination. And a permutation is where we care about the order. We don't care about the order here. We're just choosing who's coming. We're not going to put them on special coloured seats or anything like that, right? So this is simply choose 17 people out of 23. So that's 23 C17. Now you can shove that into your calculator and you're going to do that eventually. But I just want to make sure that everyone watching knows the definition of a combination, right? So it's going to be 23 divided by 23 factorial divided by 17 factorial times 6 factorial. And if you weirdly like simplifying fractions like I do, you can do some work on that before you put it in your calculator. The number that you should end up getting is 100,947 ways to choose the people. So that works out to be, so what we've got here is we've got 23 times 22 times 21 times 20 times 19 times 18. Now that's as far as I have to go because these 2 things here have a lot of common factors, right? So when you're looking at combinations, we can get rid of many, many terms before we even start. Right, so as I said, it is completely fine for you to get that number out of your calculator. You have to show this bit of thinking to get the 2 marks here, as you'd expect, but you don't have to do what I'm doing here, right? But what I'm trying to show you is that when we've got a combination, the 17 factorial is entirely contained within that 23 factorial. So we can actually knock out a whole lot of stuff here, right? We've got a common factor there, and then this is just 11. So if you have a calculator moment, that's all you're working out on your calculator. Okay, on to the next one. Lakeside and Riverside are 2 schools. The pupils at both schools took part in a competition to see how far they could throw the ball, and these are their distances thrown to the nearest metre. Now, it's really important that you read that stuff carefully because you're going to lose marks if you don't give your answer with enough context. We've got 11 students from each school, and they're shown in this table. And we have to do a back-to-back stem and leaf diagram. When we do a stem and leaf diagram, we're going to end up with something that looks like this, with numbers here. And those numbers have to not have commas in between them, and they have to be lined up nicely. The other thing we have to do is always to give a key for the reader. So at the end of it, we're going to write something like this, and we're going to write a statement saying what that 235 actually means. Because we need to get the numbers in order, you need to do a thing where you do it roughly first and then you come back and do it properly. So I'm just going to do this over here. So very roughly, because our final one is going to be nicely ruled up, our stem is going to go 1, 2, 3, up to 4. We've been told to put Lakeview on the left-hand side. It's probably to make it easier for the markers. And then we've been told to put Riverside here. So to start with, just L and R is fine. And then Lakeview actually is in the right order already. So that's going to be pretty fast. So it's going to be 0, 4, 9, 2, 6, 7, 8, 0, 2, 3, 1. But for Riverside, we're going to need to reorder. So just go through and pick out what we've got here. We've got 18 and 18 here. So scribble those down. when you're doing your rough one, don't worry too much about lining it up. And then we've got 20 here. We've got 23, 21, 25, 24, and 25. And then we've got 36, 37, and 30. So worth doing here at this point is just to count that you haven't missed anyone out, right? So we should have 11 numbers on each side, and I do, so that's all good. So now we're good to do the right one, and we're going to rule it up nicely. So I'm going to pause the video here so you don't have to watch me doing that, but just make sure that yours doesn't have commas, that the columns all line up, that you've got a key, and that you've got the key giving something in context. Okay, so hopefully that worked, and here's our final stem and leaf, right? So just things to notice again, because I'm not going to do this very slowly in the other videos that I do, but I do want to do it once. We've got labels here, right? So we've got labels here, we've got a stem here covering all the values, we've ruled it up, we've got no commas anywhere, and you can see that things are lining up under each other. So why is that important? Well, it gives you a picture of the shape of the distribution, and you don't usually get asked questions about that in the exams, but that's why we do it like that. If we put the commas in, it just makes everything get really, really messy. The last thing that we've got in here is we've got a key, and the key down here is showing some different values. They don't have to be the values from the actual data, they can just be made up ones, but they need to make it really clear that when you've got that 0.3, that means 30 metres for a Lakeview pupil, and it means 34 metres for a Riverside pupil. I think that's everything we've got to do there. But then in the next question, what we're asked to do is to find the interquartile range of the distances thrown by the 11 pupils at the Lakeview school. Now, it's really hard to do that from the raw data, but it's easy to do that from your stem and leaf diagram. So what we're looking at here is first we're going to find the median, and there are 11, so we've got 11 people. The way I do it is I think about finding that middle number, so it's going to be 5 and 5. The middle number is going to be the 6th number, and then for the quartiles, we've got 5 here, so it's 2, 2, and 1 here, and it's 2, 2, and 1 there. Now, I don't know if you do it like that, but that's my way to figure it out. So we've just got to do it for Lakeview. We don't have to do it for both. The third value for Lakeview is going to be this one here, 19, and the third from the top value here, be careful when you're doing this. This is 41, and then we want to go backwards here, so it's going to be 32. So the lower quartile is 19, the upper quartile is 32, and the IQR is going to be the difference between those two numbers, which is 13 metres. Okay, that is just a pretty easy 2 marker. Now the next question is also quite fiddly, and I'm going to do the same thing where I talk about it first, and then I'm going to show you the final histogram. When we're working with a histogram, we've got class widths that are not equal. Right, so I'll just give us some space here to see what's going on. Look at our categories. We've got time and minutes. So that first category has got a class width of 5. The next one goes from 5 all the way up to 10, and so on. What we need to do the histogram is we're going to have on the horizontal axis, we're going to have these categories, right? But we're not going to draw the frequencies in my histogram. Instead, we're going to construct a new variable, which is called a frequency density. And the frequency density is really, really easy to do, but we're just going to use the space at the top of the histogram there to do it. So the class widths are 5, 5, 10, 10, and 20, right, coming from here. And then the frequency density means that I'm going to take those 23 people and divide them by the class width. So we're getting a completely artificial measure, but it gives us a more accurate picture of what's happening in the data, right? So frequency density will be 23 over 5. Now you don't have to simplify that, but actually we might as well simplify it. So these are the heights of the bars that we're going to draw. This one here is going to be 102 over 5. This is going to be 135 over 10. This is going to be 76 over 10. And this one's going to be 24 over 20. So the frequency density numbers that we're drawing are 4.6. This is a big one. This is 20.4. This is 13.5. This is 7.6. And this one will be 1.2. Right, so what we're saying is that having 24 people, when you're spreading them out over 20 different values, or over a span of 20, is not as big of a deal as having 23 people concentrated over 5 minutes. Okay, so now we're basically good to do the drawing, except again, we've got to be pretty careful that we get everything done. So in here, let's label this axis is going to be time in minutes. So we want to give the variable name and the unit there, and we need a scale. So we want to go from, where are we going out to? We're going out to 50. Let's see, so it's going to be 10, 20, 30, 40, 50, out to here. And just mark on now, there's the 5 mark, here's the 10 mark. So your bars go right up next to each other, no gaps between the bars, because we're doing a histogram, not a bar graph. So these are the bars here. And then on this axis, we're going to label this either FD or better, say what FD actually is. So FD is the frequency density. And now we're going to put those frequency densities on. So again, I'm going to pause the video so you don't watch me ruling up bars, but we're just about there. And then we've got to find the mean. So don't hang up the video because there's an important, slightly tricky thing coming. Okay, so there you go. That's the finished off histogram. The only thing I think I need to add to it, I've got the scale, the axis labels here. We could add on a title. What are we going to do? I'm just going to put travel time. Okay, because at the moment, if you looked at that graph, you'd have no clue what it was really about. Travel time in minutes for employees. Okay, so just one more time, because I know someone out there has not been listening so far. Frequency density, we've got to put that on here, right? And time in minutes, we've got to put that on here. Otherwise, I think we chuck away 1 or 2 marks, which would be sad. Okay, next thing. Calculate an estimate of the mean time taken by an employee to travel to work. If you think about this, it's pretty intuitive, right? We don't know the exact times of the 360 employees. We just know the groups that they're in. So the most effective thing to do is to use the midpoint of each category as our estimate for what travel time those 23 people had. And if you remember that, you don't even need to use the formula that's on the formula sheet. So using the midpoints of each category, this is what we get for the estimate of the mean. It's going to be 23 times 2.5 times 7.5 times 15 times 25 and times 40. Just be careful to really watch that. And when we add all of those up, we divide them by the total number. So it's 23 times 25 plus 102 times 7.5 and so on, divided by 360. When we do that, we get 5,707.5 total minutes taken by 360 employees, and we get 15.9 minutes. Now, in this case, it's perfectly fine to have 15.9 minutes, right? So there's no reason any of you should be thinking about rounding. But even if we're dealing with a discrete random variable, for example, the number of animals, suppose that we're dealing with the average number of pets in 13 MCA, and we get our estimate is works out to be 7.2. It's a pretty high number, but we wouldn't round it, right? So we don't round the mean usually, even though it doesn't make sense to have 7.2 animals, because it's giving us more information than if we did round it. When we're working with the median, though, we'll always get a whole number. Okay, so that's all I'm going to do in that video, because that's 13 minutes already. It'd be kind of nice if someone could tell me if you're actually watching these. I'm going to do AS stuff to the extent that you want it. I suspect it's going to be useful for 13 MCA students who are resitting and haven't had much time to focus on this yet, but please let me know, because I'm choosing whether I do A-level stuff or AS stuff. So just send me an email.